Hi, everybody. It's Miss Austin, and I'm going to be helping you with the Unit 3, Lesson 18 practice problems. These start on page, I believe, 132. It says Claire solves the quadratic equation 4x squared plus 12x plus 58 equals 0, but when she checks her answer, she realizes she made a mistake. Explain what Claire's mistake was. So error analysis is a great way to make sure you understand a problem. So let's just go through step by step and make sure she did everything right. Quadratic formula is negative b, so that means to take negative 12, yep, plus or minus b squared, yep, minus 4 times a times c, all over 2a. So she's got everything right. And maybe for those of you that are still learning the formula, I mean, there's my a, there's my b, there's my c. So step one, everything's in there right. Then it looks like she multiplies these three things, right? And you would want to multiply those before you subtract because we have to follow order of operations. So let's see if that's right. So 4 times 4 times 58, let's make sure that's right. 4 times 4 times 58 is in fact 928. So 12 squared is 144 minus 928, and then she multiplied the 2 times 4. Everything's looking good. Then she goes ahead and subtracts that. 144 take away 928 and gets negative 784. Yep. And then she gets negative 12, still the same. Okay, so as soon as I see that negative under the radical, right, that stands for the square root of negative 1, and I comes out for that. And according to Claire, 784 has a square root. I don't have that one memorized, so I'm going to double check. The square root of 784 is 28. So just in case you don't understand how she simplified that, right, that's actually negative 1 times 784. So I comes out for that, and then we just type that into the calculator. The square root of 784 is 28. So this step looks good. And then the last step, right, negative 12 divided by 8 gets you negative 1.5. And then this is also being divided by 8. So here's her mistake finally. Both of these things are being divided by 8. So her mistake was 28i. So technically, I mean, you have negative 12 over 8 plus or minus 28i over 8. And then that's okay to clean that one up to 1.5. You could reduce that fraction if you wanted to. But so her mistake was she didn't divide the entire expression by 8. She only divided this one. Okay. Number 2, write in the form a plus bi where a and b are real numbers. Remember, this is a complex number. It has two parts, the real part and the imaginary part. I can tell this part's imaginary because it has the I. So what they want me to do is kind of practice what we were just doing up here and split this apart and clean it up. So 5 is being divided by 3, plus or minus, this is being divided by 3. Now, if this can be simplified, do it, but 5 over 3 can't. So we're going to leave it and then come over here and clean this up. As soon as you see a negative inside of a radical, that stands for the square root of negative 1, which means I is coming out. So now this is actually I square root of 4 over 3. But what's the square root of 4? 2. So this is 5 over 3 plus or minus 2i over 3. The square root of 4 is 2, and the square root of negative 1 is I. That's how I clean that up to 2i. All right, next one. We're going to put each of these over 2. 10 over 2 plus or minus the square root of negative 16 over 2. This time, 10 over 2 can be reduced. 5 plus or minus. What's coming out for that negative? I. And you could do it all in one step. I'm breaking it down. You could take care of the square root of 16 and take care of the square root of negative 1. Now, what's the square root of 16? 4. So final answer, 5, which we got from this, plus or minus 4i divided by 2. I can do even more. This 4 divided by 2. So final answer, final expression, 5 plus or minus 2y. Just cleaning it up all the way. All right, last one, we're going to break it apart. We've got -3 being divided by 6 plus or minus the square root of -144 being divided by 6. That can clean up to -1/2 plus or minus. Let's go ahead and let's get a little spicy and do this all at once. What comes out for the negative? I. And what's the square root of 144? 12 all over 6. You can do it in steps if you want. Now take a look at this. We've already reduced that, but this one, 12 divided by 6, 2y. And you could write 1/2 as 0.5 if you wanted. Okay? So we're just practicing cleaning up our expressions. We might get something like this at the end of the quadratic formula. All right, moving on. Number 3. Priya is using the quadratic formula to solve 2 different quadratic equations. For the first equation, she writes x equals 4 plus or minus the square root of 16 minus 72 all over 12. For the second, she writes x equals 8 plus or minus the square root of 64 minus 24 all over 6. Which equation will have real solutions and which one will have non-real? Explain how you know. So the big idea in today's lesson was to realize that you can tell just by looking at the radical. Whatever ends up in here lets you know whether or not it's real or not. If you end up with a negative under the radical, well, that means you have an imaginary number, right? So those are going to be non-real. If you end up with a positive number in here, well, then we're dealing with real solutions. So all we need to do is really look here. So on this problem, 16 minus 72, what is that? Should know that quicker. That's -56. That's a negative. This problem is going to have non-real solutions. And this one, what's 64 minus 24? That's going to be 40. Those are positive, which means I'm going to have real. How do I know? Just by looking at the quantity inside the radical. If it's negative, it's going to be non-real. If it's positive, it's going to be real. And that kind of helps you too. You know, if you know that's a negative, your final answer better have an I in it. Don't drop it off somewhere while you're doing your, simplifying. All right, number 4, find the exact solutions to each of these or explain why there is none. So this is still what we're working on now, but it touches back a little bit to what we were doing at the beginning of the unit. You know, think about it. You can do this one mentally. What numbers or how many should square to make 25? There's going to be 2 solutions. There's 2 numbers that can make a positive. Hopefully you've seen this one enough, you'll know it. Or, I mean, you can take the square root. X is going to be the positive or negative square root of 25. The positive square root is 5. The negative square root is -5. Okay, cube root, kind of throwing us a curveball here. How many numbers can I cube to make 27? Remember our picture. Here's what a cube root looks like. Here's 27. Cube roots and cubic problems always have exactly one solution, always. Maybe you know this answer off the top of your head. It's 3, because 3 times 3 times 3 is 27. If you don't, you can solve it. To undo cube, you cube root. Whatever you do to one side, you do to the other. And the cube root of 27 is 3. You either know that off the top of your head or you can type it into a calculator. All right, letter C. Just like letter A, this problem is starting out as x squared equals a positive number. That means there's going to be 2 solutions. Again, you could also think of the picture. Here's x squared. Here's 12. You can see it's going to have 2 solutions. And notice in here, they said exact. We're not talking in decimals. If it doesn't come out like number 1 with a nice whole number square root, we're going to leave it in radical form. So I don't know about you, but I don't know what exact number squares to 12. It's a complicated irrational number. So if I square root, x is going to be the positive or the negative square root of 12. You could leave your answers written like that, right? Or you could break them apart. You got the positive square root of 12 and the negative square root of 12. All right, last one, another cube root. Here's a picture of it again. Number 12 is right up here somewhere. It's going to run into it once. This has exactly one answer. What number times itself 3 times makes 12? Not a nice whole number. So I'm going to take the cube root, and just like our square roots that don't come out when we leave them in radical form, same with the cube root. And you could type this into a calculator. Hopefully you know your calculator. Mine is right here. It says x, and then it has a radical. So if you go, I have to tell it what root, 3, and then I activate that button. So that's asking for the cube root of 12. See how that's not an exact number. That's a rounded number. The calculator has rounded it. It ran out of space. So we're just going to leave it as the cube root of 12. Now, we don't write plus or minus on cube roots. Look at the picture. The cube root only runs into 12 up here. Square roots, right? That part curves back up because when you square a negative, you get positive. All right, so all of these had answers. All right, number 5. I like this question because this is a common error students make, and I don't think they understand why it's not okay. So if you were solving this equation, some people, right, the strategy that teachers teach is to isolate this first, get this alone before you square it. And some students think, well, that's silly. I'm just going to go ahead and square it first. Here's why you can't. When you square this, look at this. If you square this side and you square this side, that's a binomial. You're not just squaring that and squaring that. You know what this means? It's an awful expression. It means you're taking that and you're timesing it by itself. And go ahead and do that. This is a FOIL problem. Look at this. I have to do this times this, this times this, this times this, and this times this. Hopefully you're gagging already because you see how much work this is? That's why adding 5 over there is way quicker. Then you can square it and you don't have this big problem. So look, if you take a radical times itself, it's just going to spit out what's inside there, x plus 2. Then I have negative 5 square roots of x plus 2. I have another negative 5 square roots of x plus 2. And then finally, I have a positive 25. Hopefully you're realizing that that is why we teach you to get this alone first. See how much work this is? Now these two can get put together. So this is x plus 2. That makes negative 10 of those. And technically we would keep cleaning it up. I mean, you could put this 2 and this 25 together, but you can already see, go look over at the answer choices. I think it's C. Look, we've got the x plus 2. We've got the negative 10 x plus 2s and 25. Okay, moral of the story, way quicker. Look, when you have a problem that has a radical in it, isolate the radical before you start undoing it. If you add 5 first, then just square it, that undoes that, and that's all you have to do. I think that's 256. Miss Austin's not on her multiplication game today. 256. And then you keep solving it. You'd get the same answer for this one. That was a lot more work. All right, last question. We're going to be plotting some imaginary and real numbers. Plot each number on the real or imaginary line. So remember, this is called the complex plane. Here, your horizontal one is the real numbers, and the vertical is your imaginary. All right, so the very first one. Now, students are getting this negative out front confused with the negative inside the radical. if you want, cover up the outside one. What is the square root of 4? 2. There's no negative in the radical. This isn't an imaginary number. And then there was a negative. So this is negative 2. So I'm going to go plot that. That's a real number. I'm going to plot negative 2. I'm going to put letter A right there. The square root of negative 1. Bells and whistles should be going off. There's a negative in that radical. That means it's imaginary. And as a matter of fact, it's just, right, what we've defined as I. The square root of negative 1 is I, or 1I. So now we're on the imaginary. And they left it like this, right? So maybe you didn't even need to think of that. If that's 2 times square root of negative 1, well, this is 1 square roots of negative 1. That's B. C. 3 square root of 4. If two things are touching in math, that means they're multiplying, right? So that means 3 times, what's the square root of 4? 2. What's 3 times 2? 6. This is a real number. Letter C is the number 6. Okay, letter D. That's an imaginary. And they left them like this. We don't even have to think about this. Technically, this is negative 3I. But they left them in this form. Go find it. Look, there's negative 2I, or negative 2 times the square root of negative 1. So that would be negative 3 negative square root of 1. Negative 1, negative 2, negative 3. Again, look at this one, E. The way they wrote them is exactly this way. It says it wants 4 square roots of negative 1. That means it wants 4I. Well, it's right there. Look, 4 square root of negative 1. And then the last one, hopefully you know it's real because it's not negative under that radical. 2 square root 2, that means 2 times this. Well, 2 doesn't have a nice whole number square root. So let's go figure out what it is approximately. Square root of 2 is about 1.41. And then I'm multiplying that by 2. So it's about 2.82. So that would be, here's 3. So it's right before, there's letter F. Okay, I hope that was helpful. I'll see you soon.